My name is Weidong Yang. I'm CEO of Kineviz. Kineviz is San Francisco-based data visualization company. Right now we focus on graph data visualization as well as high-dimensional data visualization. Kineviz has been around for about 4.5 years. In the first few years, Kineviz has been operating most as a consulting base, and people probably don't know that we also have a parallel art nonprofit company, which is bringing dance interactive technology visualization together. So we learn a lot about how we experience things, how we perceive information, perceiving very subtle cues from artistic explorations. And we bring those art understanding and exploration into data visualization, into working with the data. And believe it or not, working with the data is often an art than engineer. There's so much information that you have to use a lot of intuition to get there before you can actually figure out what is quantify it. Kineviz has been focusing on bringing, we call it bringing wonder to data. Essentially, we bringing those hidden complex information out. Often is high-dimensional data informations and time, spatial informations, and present in the way that we can understand. Not exactly in the quantifiable way, but more qualitatively we can sense some interesting things that's going on, sense some things happening, and then from there give us a cue to figure out what exactly to dig into to get quantifiable results. I have to tell a little bit about the stories. So about 6 years ago, I was on another startups. We built a startup. We're trying to use social networks to build kind of a trust system for sharing economy. Now this is a lot of company does that. It's quite successful. But around 2011, 2012, it was still early. So one of the things that we investigating is using leverage networks and to figure out how can trust somebody and where you can trust somebody, or who are the people that you likely can they can pair, they can work together, they can share something together. And so we did a lot of graph work at the time. Without actually using any graph database, we actually built a lot of our own graph visualization engines, and mostly 2D. And the one problem we encountered at the time was once the network graph grow above certain size, it becomes very difficult to see. All the structure gets smashed together. The local clusters, even though they may be separated, but if they have some connections, they very likely smash together. So later on, a few years later, we start trying the 3D technology, and we realized that it can let you see the information much more clear, the separation of clusters much easier. At that time, we're still using our own built in-memory graph engine. So we did a lot of heavy works trying to build a lot of graph algorithms. Last year, actually, believe it or not, it was only last year this time where we're serious about thinking about, wait a minute, Neo4j seems to have solved all the hard problems we're trying to solve. Let's try that. And we start integrating our solution with Neo4j, and that was the aha moment. Realize, oh, okay, so things become so much easier, and which the critical things allowed us to focus on what we do well, which is visual and interactivities, and leave a lot of hard data problem to Neo4j. I think that makes a lot of sense, and I can offer my view about why Neo4j matters for us, and especially from my own background perspective. I'm a physicist. I'm a trained physicist, used to work with quantum dots. So in my career, we build models all the time. We deal with data all the time. most time the data is like a table format, a column, row format. But very often it's also relational format. Very often you have different entities like closely correlated with each other, like coupled with each other. So to understand, to get insight into such complex either modeling problem or data problem, visualizations always has to be one important tool for me. To like once you can see something, it helps you to gain some intuition, and then you can lay out some work to get quantitative like result out that you can communicate to people. So I've been always found out that high dimensional problem is particularly challenging. The reason is like, let's just give example of like the architecture blueprints. Like if you are trained architect, yes, you can look at the blueprints, you can make sense of it. But for like model people like you and I, look at the drawings, blueprints, we probably have no clue. So that's a perfect example of an architecture is a three-dimensional structure. You trying to represent in the two-dimensional space, it's very difficult. It takes a lot of brain power to reconstruct. So the same thing happens in high-dimensional data set. When we deal with high-dimensional data set, if you have to look at the two-dimensional thing, it's become very difficult. Having an extra dimension is not an incremental but qualitative jump. Guess what? Graph is hard-dimensional problem because all the nodes together, like in each pair of the nodes, there's interaction. That's your dimension. So the graph is a special case, is a very, very high dimension problem that's extremely difficult to deal with. I think the graph is very promising. The graph is very important. For example, we all know that our experience with the knowledge is all essentially graph. It's how things relate to each other. But graph as a tool for understanding, for analysis, it's still in I would say at the beginning phase. I think there's a lot of technology and not a lot of problem needs to be answered, resolved. And for example, it's very easy for a graph become complex. Like when you only have a few entities, like it's easy to think about it, to reason on the graph. But when the graph is become big, complicated, our brain can make sense of it because it's the too many dimensions, too many things in play. So I think there's a lot of experiment and research needs to be done on making graph accessible and making it easy for people to understand, to be useful in all kind of applications. I like to offer one thought. It's as a data, from a scientist's perspective, working with the model and the data, I think there's a set of space that Neo4j offer a great solution, or possibility of solution, which is when you deal with information that's graph in nature, but also has a large quantity of them. So what I mean is, let's say you have a few labels, but each label you have a lot of entities and you have many properties. So this is a traditional like data problem mixed with the graph problem. And because of the label property graph is very well positioned to address that area.